Okay, here are solutions for circular motion. First question asks, what's the difference between a rotation and a revolution? So for a rotation, this is an object spinning on its own axis. Think of spinning a basketball on your finger. That object is rotating. A revolution, that's an object spinning around a center point somewhere. So think of a ball on the end of a string. That ball is doing a revolution. It's revolving around something, whereas a rotation is just on its axis. So rotation is the ball going around in a circle. A revolution is the ball going around in the circle, and then the rotation is the spinning along its own axis kind of thing. Okay, so these are three very important ideas: period, frequency, and tangential velocity, or linear speed of an object. So the period, that is the time for one complete revolution, one complete circle. We use a big capital T for the period. Frequency is the number of complete revolutions or complete circles in a second. And then tangential velocity is just the object's speed, how fast it's going. So period, we use a T for, and that's going to be time per revolution. We use a capital T because it's an important time. It's 1 over the frequency. Frequency is revolutions per time. That's how you would calculate it. That's just the inverse of the period. We measure the period in seconds because it's just the time. We measure the frequency in hertz, which is a 1 over a second. And then tangential velocity is 2 pi r over the period. That's the circumference divided by the amount of time it takes to go around one circumference, or divided by the period. Or it's 2 pi r times the frequency. That's when we use frequency instead. It's just the inverse of the period, so it goes on top there. That's measured in meters per second. All right, so we have a child on a carousel at the fair, and it's rotating with a constant frequency. He moves from the inside circle to the outside circle. So for this kid, his frequency doesn't change. He's still going to go the same number of turns around per unit time on that object. So the frequency does not change. It's the same. Same deal with the period. It doesn't change either. It's the same. It takes just as long for him to go around if he's on the very outside of the merry-go-round than it does if he's on the very inside of the merry-go-round. Does his linear speed change? Absolutely. Okay, sorry. So for these, the frequency and the period only depend on how long it takes the whole thing to go around one time. It does not depend on the radius. It doesn't matter where you stand. The linear speed, however, changes. The farther out you go, the faster you go. The linear speed depends on the radius. If we look at that formula, it's 2 pi r over the period. The velocity increases if the radius increases. All right, question 4. Is the Earth's motion a revolution, a rotation, or both? Well, it's both. The Earth is doing two things. It rotates around its axis. That's the spinning. That's why we have days. And then it revolves around the sun. That's why we have seasons. Also the tilt. There you go. Ricky and Billy are standing on a merry-go-round. Ricky's 2 meters from the center, and Billy is 6 meters from the cylinder. Carney, somebody at the carnival, uses a radar gun to measure Ricky's linear speed, and it's 4 meters per second. So for Ricky's period, what we have to do is velocity is 2 pi r over the period. But for Ricky, we know his speed is 4 meters per second. 2, and then for pi, we're going to do 3.14 times the radius. Now for Ricky, his radius is 2 meters. We know how far away he is, divided by the period. So we have to solve for the period. It's on the bottom. We're going to multiply both sides by the period. We're going to divide, because we want period by itself now, both sides by 4 meters per second. period crosses out, those 4's cross out, and we get 2 times 3.14 times 2 divided by 4, or that the period is 3.14 seconds. Then if I want his frequency, it's just the inverse of the period. So frequency is 1 over the period, so it's going to be 1 over 3.14 seconds, so we get 0.32 hertz. I'll go back and change that in a second. What's Billy's period? It's the same as Ricky's period. They are both going to have a period of 3.14 seconds. They're going to take the same time to go around. Same amount of time to complete a revolution. 3.14 seconds. What's Billy's frequency? Also the same. They will do the same number of revolutions per second. It's 0.32 hertz. Okay, we'll change it now. And then to get Billy's linear speed, velocity is 2 pi r over the period. For Billy, 2 times 3.14, that's not going to change. But for Billy, his radius is 6 meters. I'm going to divide that by 3.14 seconds, and it gives me a speed of 12 meters per second. That's how fast Billy's going around.